Assalamu alaikum. Welcome back, guys. So let's continue with the discussion where we left off last time. We were discussing discrete random variables, and I discussed probability distributions and mean and standard deviation of probability distributions for discrete random variable. The next concept is a distribution function of a discrete random variable. So what is the distribution function? It comes from the probability distribution, of course. The distribution function or cumulative distribution function of a random variable x denoted by fx is defined by probability of x less than or equal to x. You see, the probability of x was capital X equal to x. At some point, what is the probability? If we add all the probabilities up to some number, we call it cumulative probability, right? If I add, like in the case of cumulative frequency, if we keep on adding up to some group, we call it a cumulative frequency. Similarly, here this capital Fx is basically a cumulative distribution, and this is not just a probability, it is a function. X can be any number here, so it depends on x, right? So that's why we call it cumulative distribution function or simply a distribution function. So this function capital Fx gives the probability of the event that x takes a value less than or equal to a specified value x. So the distribution function is abbreviated a df for distribution function, and is also called the cumulative distribution function, CDF. So you can call it any, CDF or DF, both are fine, because it gives you the cumulative probability of a random variable, right? So let's illustrate this concept with the help of an example. This is the example which we studied earlier when two dice are rolled and x denote the sum on two dice. You remember, when x is the sum on two dice, then x can be from 2 to 12, because the sum can be at least 2 and it can be at most 12 on two dice, because 6 and 6 are the maximum, so 6 plus 6 is 12, and 1 and 1 are minimum, so 1 plus 1 is 2, right? So it can be from 2 to 12. And if you go back to the previous lecture, we found out the probabilities as well. The probability that the sum is 2 is 1 over 36. The probability that the sum is 3 is 2 by 36, and so on, right? So we have all these probabilities. Now, if you want to calculate the distribution function, first of all, we will calculate the cumulative probabilities of all these numbers, right? So what I will do, if small fxi is the probability, then capital Fxi is the cumulative probability. So the first one remains as it is, you see. But then we add this number and add it here, right? So we will add this and write it down here. So that will be 3 by 36. You see, 1 by 36 plus 2 by 36 is 3 by 36. So this is added here and come back here. Now if you add this number, 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. 21 plus 5, 26. 26 plus 4, 30. 30 plus 3, 33. Plus 2, 35. Plus 1, 36. Right? So these all are cumulative probabilities of the function. But this is not just a table. Distribution function is not just a cumulative probability. Remember that. So to write a distribution function, what we will do, we will write the function of x for any x real number, for any real number x, not just for 2 to 12. Distribution function can be written for any real number. It can be 1, it can be 13, it can be between them, 4.5, 7.8, anything can be there, right? I will write that distribution function later on. This was the example where you had 3 balanced coins are tossed. So if we toss 3 balanced coins, you know that the probability distribution for that is this one, because there are 8 possible outcomes, 2 to the power 3, 8 possible outcomes: head, 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 tail, head, tail, head, head, tail, tail. Then tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are 8 possibilities. And what is the probability that we get a 0 head? Is just 1. 0 head means all 3 tails, so only one event, tail, tail, tail. So 1 divided by 8. Similarly, probability of 1 head is 3 by 8, probability of 2 head is 3 by 8, and 3 heads is 1 by 8. If you add all of them, the sum is equal to 1. 1 plus 3 plus 3 plus 1 is 8 by 8, which is 1. So this is the PDF, the probability distribution, discrete probability distribution for X, where X is the number of heads when 3 coins are tossed. So this is what I got, right? Now, see the bar chart of this distribution, probability distribution. I can easily make it, of course. You see, at 0, you have 1 by 8. At 1, you have 3 by 8. At 2, you also have 3 by 8. And at 3, you again have 1 by 8, right? So these are the bars. So this is called the bar chart or line chart. Both names are used, bar chart, line chart. Some people call it probability histogram as well, but very rare. Okay, because you see, we are not making rectangles. We are making bars here or lines here. So these are called bar charts, line charts. Okay. Now, if I want to find the cumulative probability here, how I can find? You see, this 1 by 8 is the same, but then we add 3 by 8 in 1 by 8 and write 4 by 8. So 1 by 8 plus 3 by 8 is 4 by 8. 4 by 8 plus 3 by 8 is 7 by 8. 7 by 8 plus 1 by 8 is 1. So you got, of course, cumulative probability at the end will definitely give you 1, because the last one is the sum of all probabilities. It has to be the 1. How I write a probability distribution? This is the cumulative probability only. This is not the distribution function. So what is the distribution function? Distribution function is capital Fx. Where we write this Fx for all real numbers from minus infinity to plus infinity. Okay, so if X is any number less than 0, there is no probability for less than 0, you know. If your X is less than 0, what are the probabilities below it? There was no probability, so answer is 0. Right? Now, if I pick any number between 0 and 1, if I pick any number between 0 and 1, 1 is not included, you see. For any X between 0 and 1, 1 is not included. If I pick any number between 0 and 1, what is the value below it? Below it, only 0 is the value below it, right? So 1 by 8 is the answer for that. Only 0 value, right? Now if I go between 1 and 2, 2 is not included. I am between 1 and 2. So between 1 and 2, if I want to find the probability below it, both 0 and 1, both 0 and 1 will be included. 0 and 1 both will be included for any number between 1 and 2, for any number here. So it means I need to add these two probabilities, which is already stated here, 4 by 8, right? So my value of capital Fx for any X between 1 and 2 will be 4 by 8. Similarly, between 2 and 3 will be 7 by 8. Between 2 by 3 will be 7 and 8. And now because 3 is the last number, so if I pick any number after 3, if I pick any number after 3, everything will be included, and this will be my answer, 1. Right? So if I pick any number greater than 3, my probability will be the whole thing. If I pick any Fx, let's say I want to find what is F at 3.5. If I pick any Fx between 3.5, it means it contains all the values less than or equal to 3.5. I know that below 3.5 I have 0, 1, 2 and 3. So I have to add all of them. So it has to be equal to 1. I know that, right? And the same thing is coming from here. It is 1. Right? So if I pick any number, let's say from here, if you want to say that what is F of 0.9. So 0.9 is in this interval, so the answer is 1 by 8. 1 by 8. But if I pick any number, let's say if I pick 1, then 1 is here, not here. 1 is here. So f at 1 will be 4.8, f at 1.1, 1.2 up to 1.999 it will remain 4.8, but once I get to f of 2 it will become 7 by 8, and then f of 2, f of 2.1, 2.2, 2.5, 2.9, 2.99, 2.999, I will remain in this interval, my answer will remain 7 by 8, right? So this fx is for all real numbers. You see, I started from minus infinity to plus infinity. So we started from minus infinity, but we had the break at 0, break at 1, break at 2, break at 3, and then up to infinity. So I have the values at all real lines from positive infinity to negative infinity. So I can pick any number. Let's say this 0.9 was here, right? So for this number, my probability distribution function gives you the value 1 by 8. And what does it mean? It means this is the probability of x being less than 0.9. So less than 0.9 means only 0. So 0 probability is 1 by 8. All right. So basically how we can interpret this, if x is less than 0, we have probability of x less than x is 0, because there is no possible outcome for the random variable less than 0, right? So that's why the answer is 0. But if we are between 0 and 1, note that it is not possible for our random variable to assume value between 0 and 1. And we are not saying that. We are only saying that if we are between 0 and 1, then only 0 is the possibility. Right? So hence the probabilities of all such values will be 0, and hence we will obtain a situation which can be explained through the following table. So basically, you see, if I am between 0 and 1, all these probabilities are 0. We are not getting anything for this. We are only getting the probability for 0 and then probability for 1. So if I keep myself between 0 and 1, 1 is not included in this part, right? My cumulative probability does not change. You see, 1 by 8, 1 by 8, 1 by 8, so on. Once I reach 1, then it becomes 4 by 8. Now from 1 to 1.99, it will remain 4 by 8, because all the probabilities 1.1, 1.2 will be 0. There is no such outcome of a random variable between 0 and 1 or between 1 and 2, but your distribution function is defined for any real number. Alright, so this is the explanation how we got for any number between 1 and 2. This is my PDF distribution function, sorry, CDF. Between any 2 and 3, this is my CDF. And finally, if I am greater than 3, this is my CDF. So you can easily see, if x is anything greater than 3, it means 0, 1, 2 and 3, these all are included, because my this x includes 3. So from 0 to 3, all probabilities are included. If I am between 1 and 2, only 0 and 1 are included, because I have x which is less than 2 but greater than 1. Greater than 1 means 0 and 1 are included, less than 2 means 2 is not included. So we just added 0 and 1 to get 4 by 8 and so on. Alright, so whenever you write a distribution function, it should be something like this, which gives you values for all real numbers. And if you want to draw the graph, it will always be a step function. You see, if you draw the graph of this one, 0, and it jumps to 1 by 8, next jump to 4 by 8, next jump to 7 by 8, and next jump to 1. So it will be, you see, at from 0, less than 0, it is 0. Between 0 and 1, you are at 1 by 8. From 1 to 2, you are at 4 by 8. From 3, you are at 7 by 8. And after 3, you are at 1. So this circle means that at 2, this is not the point. The point is this. At 2, this is the point. Right? So this is what a circle means, that at 2, this is the value which I am getting, not this. So at 1, this is the value I am getting, not this. Okay, so this is the circle means that at this point 1, I have a circle value. At 2, at 3 we have 1, not 7 by 8. Right? At 3 we have 1, not 7 by 8, and so on. So see, this is a step function. They looks like steps, right? So every time a distribution function of a discrete random variable will be a step function. So this is another example. Let's go through this example. A large store places its last 15 clock radios in a clearance sale. There was a store who had some clock radios, last 15 were left, so he's put them on sale. Unknown to anyone, 5 out of the radios are defective. No one knows that. Even the store keeper does not know that 5 of them are defective because they are on sale. So it's your luck now if you pick a good one or a defective one. So if a customer tests 3 different clock radios selected at random, out of 15 he selected 3 clock radios and tested them. What is the probability distribution of X, where X represents the number of defective radios in the sample? Defective radios in the sample. Now you see, we selected only 3 clock radios, and out of 3 there can be 0 defective, there can be 1 defective, there can be 2 defective, or there can be 3 defectives, right? So out of 3 sample radios, at least we can get 0 defective radios, or we can get at the most 3 defective radios. So X will take the values from 0, 1, 2 and 3. Now let's make a small table. We know that there are 15 total radios. 5 are defective, so it means the remaining 10 are good. They are not defective. So the total number of ways of choosing 3 radios out of 15 is 15C3. We use combination. When we pick a sample at random from a bigger lot, and the order does not matter here. I'm just interested in 3 clock radios. Which comes first, which comes second, I'm not interested in that. So that's why we are not using permutation, we are using combination, 15C3. Now, what is the probability that we get 0 defectives? So if I total number of ways selecting 3 good radios means no defective radio, what will be that? All 3 come from good and no come from the defective. You see, 10 are good, so 10C3 means all goods are selected. 5C0, defectives are 5 and no defective is selected. So it means what is the probability of X is equal to 0? 0 defective is total number of 0 defectives divided by total number of 3 selected, right? So this is the probability of selecting 0 defective. So if I continue with that, I got all of them. For example, if I want to write another formula, let's say for this one, where I got this from. This is 10C2 because I am selecting 1 defective. I am selecting 1 defective, it means 2 will be good. So if 1 is defective, 5C1, remaining 2 will be from 10, which are good, and divided by 15C3. Total is 15C3. You see here 10 plus 5, 15 total, 2 plus 1, 3 total. Okay. Alright, so let me erase this. So this is 15C3, right? So that's how we find the probabilities. So all of them are given like this. So you see here, of course, we are rounding these numbers. That's why this is 0.99. 0.99 is also equal to 1. So this is the probability distribution. This is the bar chart related to that, and you can find the cumulative frequency as well. From small fx we can find capital Fx. So this is the cumulative frequencies by adding, right? And from here you can write down the fx for all real numbers as well. All right. So the next concept is about mathematical expectation. We already did this in the previous lecture. If you recall, in the previous lecture I calculated mean, and mean was expected value of x. So that is called mathematical expectation. All right. So if your values of a random variable x are given from x1 to xn with the corresponding probabilities, you can write them px1, px2, or fx1, fx2 is the same thing, such that all the probabilities equal to 1. So then expected value of x is this. You multiply each xi with its probability and add from 1 to n. So multiply x1 with fx1, x2 with fx2, xn with fxn, and add them up. This is expected value of x. All right, so this is mathematical expectation, and it is called the mean. Of course, it is the mean of x, expected value of x, or mathematical expectation of x. All three names can be used for this one. All right, similarly, if you have here as an example, if it rains, an umbrella salesman can earn $30 per day, and if it does not rain, if the weather is fair, then he loses $6 because no umbrella is sold, so he loses $6 per day. So what is the expectation if the probability of rain is 0.3? So you see, if it rains, right, you earn $30, and what is the probability of rain? 0.3. If there is no rain, you lose $6. It means it's -6. So the probability of not being rain is 0.7. Of course, it's 1 minus 0.3 is 0.7. Okay. Now, if you multiply them, if you multiply these two numbers and add them, this gives you the expectation. This is the mean. Okay. So hence, expected value of x is 4.8 per day. That is, on the average, the salesman can expect to earn 4.8. Similarly, we can find the expectation of some other function. If there is just an x, right, we multiply x with fx. But if there is some other function inside, if there is some other function h of x inside, what you will do, you will calculate the value of h at x1 and then multiply with the probability. You see, h at x2, h at xn. So you can find, for example, if you want to find the expected value of ex minus mu whole square, you can find that. You can multiply x minus mu square, you see. You can multiply x minus mu square with fx and sum. Take the sum. It will give you expectation of that. And you know that the mean of this is called the variance. Okay. So this expected value is called the variance. So if I simplify, I can write ex minus mu square as this. So the formula for the variance is this. This is the same formula which we used in the previous lecture. And if I take the square root, it will give me the standard deviation as well. All right. So you can find these things very easily. These are some properties of expectation as well. Very simple properties of expectation. I hope you can easily do that. So here is one example where you can find the mean and some other means as well. So just go through this example. This is very simple example, the same as we did before. So x and px are given, fx are given. You can multiply x with px, you got the mean, right? Here he is asking you to find the mean of 2x plus 3. So what we will do, from x we will calculate 2x plus 3 and multiply this 2x plus 3 with px. And if I take the sum, this will be the expected value of 2x plus 3. All right. And from here, you can verify this property as well. This is the property. If you find the mean directly or from this property, you can see that both will match. You see, this is 6 from directly. And if I use the right hand side, this is also 6. All right. So this property is satisfied. So this is all about discrete random variables. I hope it's not very difficult for you guys. You can easily go through it. So go through the notes, go through these video lectures. I tried to explain everything. I think there is nothing left. If you still have questions, you can send me in your in WhatsApp group any question as a voice note or something. I will try to explain more, and I'll try to answer as soon as possible. Good luck, guys, and I hope you are enjoying this method of learning. I know it's a little difficult and it's maybe the first time in your life you are doing like this. So hopefully things will be okay soon and we will get back to the university and regular classrooms. Next time, in next video lecture, I will discuss continuous random variables. All right, so discrete random variables are done.